Okay, so our second rule for this section is the natural log rule, which says that the natural log of x goes to 1 over x. So again, that is our rule that we need to know. Natural log x, when you take the derivative, will go to 1 over x. Now, if you apply the chain rule to anything besides x, so if it's not just a single x or t or whatever variable you might be working with, then this becomes natural log of u, where again u is this inner argument. It could be anything. So again, it's not just x, it's anything. In that case, the derivative is going to be u prime over u. And the reason for this, just very quickly, is that this u prime is like your derivative of your inner function, and this u is the derivative of the outer function. So when we are talking about the natural log, if it's just x, it's going to go to 1 over x. But if there is a more complex argument, then we need the chain rule because this inner function will be the argument. So that's where it becomes u prime over u. Now, the way I like to remember this u prime over u is that it's going to be the argument of the natural log in the denominator, and then in the numerator, we put the derivative of the argument. So a lot of our work is going to be identifying what that argument is. And remember, in general, the argument is the first term after the ln. So the first term after that ln notation. So if you look at this first example, all of this x squared minus 10x plus 27 is the argument. So that would be the argument, or the u in this case. So using the natural log rule, our y prime is going to be u prime over u, or again, derivative of the argument over the argument. So here, my argument for this particular function is x squared minus 10x plus 27. And then in the numerator, I take the derivative of that argument. So the x squared goes to 2x, the negative 10x will go to a negative 10, and then the plus 27 goes to 0 because it's a standalone constant. Now, most of the time, as soon as you differentiate and plug into this u prime over u rule, there is no simplification further to do. Technically, you could factor and cross out factors. Here, if I factor this 2 out as a GCF, there's not going to be anything to factor out. And so this would be our final answer. So for most of these questions, it's just as simple as plugging into this u prime over u rule, or you can think about it as the derivative of the argument divided by the argument.